Hey everyone! Today we're gonna talk about tests, and in particular about tests which you can write as a front-end software engineer. Tests save you from breaking stuff without noticing that. Just imagine you are working on e-commerce store. You deployed something, it might be Friday or any other day, and after just few days, you realize that you didn't receive a large chunk of orders just because order button didn't work in specific scenarios. In order to mitigate this kind of issues, we're gonna cover 8 different kinds of tests which you can write as a front-end software engineer. As more expensive downtime of your application becomes, as more reasonable tests appear. It also depends on how frequently you deploy, but generally when your scale and your application becomes bigger, the need for tests, especially front-end tests, becomes very obvious. You don't really need to know any specific framework or technology in order to understand this video. Furthermore, I will try to abstain from focusing on some of them. I just wanna let this video to be relevant longer and don't really depend on some specific stack. We're gonna test 3 different things. First is the business logic, if our code gives expected results or interactions with UI are predictable and lead our customer to expected result. Second one is the looks of our application. We want to ensure that under different conditions, the look of our application remains the same. Last but not least is semantics of our app. We want to ensure that our application is accessible. We want to be sure that people, customers, who use our application with keyboards and screen readers could use it. This video ended up being large, but I want to keep it this way. I think it might be a good reference for the people who have never had a chance to write front-end tests and are not familiar with the ecosystem of front-end testing, or for those who had already had a chance to write some front-end tests and they just want to get some additional insights on what they could do. Since this video is large and probably you came for something specific, I added timecodes in description below so you can skip the part you feel the most interested in. And from time to time there will be some notes with additional information. They will be specified on the left-hand side of me. So let's get started. What kinds of tests exist? Let's start from the small and grow to the big ones. Unit tests are there to evaluate the tiny blocks, the tiny pieces of your code. When you write unit tests, you don't really focus on user interface, but you focus on the code and you test the code itself. How the function or a method works. Is the object constructed properly, and if inheritance worked in the way it is supposed to? Unit tests are here to help. Unit tests, one of the cheapest and fastest tests to write and to run. It makes them efficient and really helpful, but if they are so good, why would we need other kinds of tests? In reality, two perfectly working things in isolation could break apart when you put them together. Also, some features are just inconvenient to test with only unit tests. It's especially true for event-driven architecture of the front-end and everything what is tightly coupled with the interface. So, when you wanna put a couple of small things together and test if they work, it's gonna be called integration tests. Heads on, terminology controversy here. First of all, we are talking about front-end integration tests, not back-end ones. And second, I've seen different people put in different opinion and meaning into integration tests. In this video, we'll settle on putting some small things together, rendering them in isolation. It's what we're gonna call integration test. What's really cool about integration tests, and I feel so excited about, is availability of different rendering engines you can use. You can think about them as different environments where you can render your code. It could be either browser, if you want to opt for environment you used to work with and some flexibility, or it could be programmatic renderer, which enables you to run your tests much faster. Good candidates for integration tests are small reusable parts It could be inputs, drop-downs, buttons, but also little bigger chunks such as grids or some sort of cards, charts, all the kinds of stuff you're gonna reuse across your application. Writing integration tests also makes you be a better developer as a side effect, since you now have to think how you're gonna write an integration test for your component and how you're gonna pass different dependencies into it. Integration tests work really well in modern frameworks. Component-based architecture is very suitable for taking one piece apart from the app and testing it in isolation. Having an ability to pass all dependencies which your component needs as properties enables you to open new horizon on how you test your application, since you don't really depend on any source of dependency injection anymore. It makes stubbing and mocking process much simpler. So good. We took some stuff, we rendered it in isolation and we tested. But how are we gonna check that those little bit bigger parts work when we build them into even bigger parts? It's time to render all applications together and see how it's gonna perform in a browser. And the idea is to open the application and script is gonna imitate real user behavior by interacting with the interface, with the same buttons, inputs, and other controls which you have in your application. But in order for your whole application to work, now you have to handle all side effects which it incurs, such as HTTP requests or WebSockets or anything else you could use. There are two ways to address it, which creates two separate categories of tests. When you mock backends, either by setting up a mock server or intercepting requests in service workers, you go into category of acceptance tests. This approach is gonna enable you to test the whole application without wasting many resources on your backend infrastructure. Keep in mind that acceptance test isn't the fastest test itself, so it's gonna consume some resources. Acceptance tests come with their own limitations. Let's think about something what is tightly coupled between front-end and the backend, some sort of type ahead which sends different queries to the same endpoints and expects to get different results, or a couple of interconnected endpoints which are orchestrated on the front end. For this situation, it's usually enough just to check if requests are shaped correctly and if you can handle a backend response, but probably it's not the best candidate for acceptance test. Welcome to dangerous area. The place of regrets, the easy way to desolation and solitude. It might be one of the most expensive mistakes you have ever done in your career. And now, when you are finally scared, let's talk about end-to-end tests. End-to-end tests are the ones which you're gonna run against real frontends and also real backend environment which is pinned specifically for those tests. As you might expect, it's not the cheapest sort of test to write, and basically it's much more expensive than anything we were talking about before. While it kind of works for smaller projects, it really scales badly once you grow. In a perfect world, end-to-end tests were supposed to be a last line of defense. The check of critical functionality in order to ensure that your application isn't broken completely and critical business flows can be completed. Since we live in perfect worlds, it's not exactly like that. Why? In reality, end-to-end test is one of the easiest tests to write. Let's think, you don't really need to know anything about architecture of your code. You might have had some team of QA automation engineers who are writing tests, and it was also a handy kind of test for them to write. It's very straightforward. You open a browser and you just write a script which is gonna replicate human behavior. Click a button, fill an input, wait for the result, go to the page and see if something is present on the page. It's a large simplification, but generally it's the whole conception behind end-to-end tests. Avoiding end-to-end tests, like any easy shortcut, requires discipline, which is not always there. Excessive end-to-end usage could be often found on two categories of projects. First one is companies which didn't put enough efforts onto front-end testing in the very beginning, probably because they thought it's not really that important, or they had a specialized team of manual testers and they thought it's a good way for them to go. When they scaled, they realized that they have to have some automated tests, and they decided to go for end-to-end, since it was the fastest way to achieve something, to get their application tested, and they just settled on this approach. Or even worse, there might be a company which didn't test their backend as well, and they used end-to-end as a workaround for testing whole application together, expecting that this test is gonna also indirectly test the backend code as well. While technically it works, it's definitely not the best solution to achieve any of those goals. As I mentioned before, the main caveat is scale, and eventually application excessively covered with end-to-end tests is gonna consume hours to complete all of them. It becomes a real pain when you have multiple deployments per day and you try to use some CI/CD system. Second problem of end-to-end tests is a large dependency on your backend infrastructure. It's not always controllable environments. You might depend on some third-party providers, and also you could use some asynchronous architecture or positive assumption responses. While it might work on scale for large clouds and stuff like that, it might break apart when you run it in isolation as a small piece. Since a lot of end-to-end tests are gonna send hundreds, thousands of requests in a really short span of time, it's easy to overload the small testing environment which you spin for the backend. It's quite expected that you are not gonna run the full-fledged environment which you have for your production, for your testing, and often you can end up having your backends breaking unpredictably. Problems like something hasn't been indexed yet, or it hasn't been cached yet, or entity hasn't been completely saved to the database are very common companions of end-to-end tests. Those unpredictable behaviors cause your tests to fail, since you received not something what you have expected and your application basically fell apart. Those unstable or so-called flaky tests could make you invest even more resources in your testing infrastructure just to mitigate the problem itself. Now, let's talk about endpoints. In order to check if they are consistent, there is something what is called contract testing. If you never heard of contract tests, don't worry about that. Contract tests check request and response bodies. What those bodies are? Those bodies, also called shapes, are basically the structure of JSON or anything else which you use to communicate between your backend and the frontend. Simpler tests just gonna check if responses are correct and compare JSONs, while more complicated ones could check the whole communication altogether. There are such powerhouses as PAC tests, which stands for provider and consumer tests, which enable you to mock specific parts of a backend and have tests of different services in isolation for their contracts as well. But it's a really interesting topic and deserves a separate video on it. Now, let's talk about accessibility tests. Accessibility tests emerged relatively recently, alongside with growing awareness of business about accessibility and also large efforts which development community puts in it. Accessibility tests don't enforce some specific implementation or technology. Furthermore, they could be nicely spread across your integration end-to-end and accessibility tests. The first one, absolutely essential and important part of web accessibility which you want to cover with the test, is keyboard navigation. It is a very important way of using your website. People with visual impairments who couldn't see clearly, they use keyboards. They operate with tab button, they click arrows, and basically they shift the focus location. Screen reader tells them what is exactly there in focus, and based on what they hear, they decide what to do next. It also applies for people who couldn't physically use mouse, they also use keyboard instead. So don't underestimate the importance of keyboard navigation, and it's also a good place to start. Second thing you might want to test with your accessibility test is screen reader support. Basically, it's not what you get for free when you develop your application, again, on pair with keyboard navigation, even though there were a lot of efforts put in screen readers themselves and they are smart enough, you still need to help them to navigate the user. It often involves adding some additional tags or having some specific markup in your application. And basically those tags and markup are good candidates to be tested as a part of accessibility test. Just check if they are present in HTML and what they say. The third one is what our customers can see. There are specifications on how stuff should be looked in order to remain accessible. The specification name is called VCAG, and by the moment of creation of this video, the relevant one is 2.0, but since there is a constant work involved, expect new versions to appear. This specification basically says that, okay, contrast ratio should be like this, and you shouldn't focus solely on the colors, because colorblind people could have troubles differentiating green and red elements which don't have additional indication in them. It is a very common problem in forms when you fill inputs and based on validation results, you highlight it with either green or red, which for colorblind people might look exactly the same. So as a part of this test, you want to ensure that people with various visual disabilities could see content of your website properly. Another good idea to check if the forms work correctly. Like, just imagine using your website with a keyboard. You hit submit and validation failed. What's user gonna see? What's user gonna hear if the user couldn't see? There is no an easy answer, and it's something you would probably want to put some thought in. There might be other things you want to check as well, like existence of subtitle for the contents or replication of the text with audio, depending on which exact specification you support. Since we already had a chance to talk about what our customers and users see, let's check how our application looks like. Neither of tests, which we were talking before, actually checks the representation. Even though CSS is a large part of our application and markup is even bigger part of it, we didn't really check it before. The most obvious idea which comes to mind is to check visual things visually. The idea behind screenshot tests is very simple. When you create a test for either some small components or a bigger chunk or conjunctions of them, you create a screenshot. Every consequent run of tests is gonna create a new screenshot and compare it to the reference screenshot you created before. If they match, test passes. If they differ, test fails, and you have to decide if it's real failure or you did a change and your screenshot needs to be updated. There are several technologies to achieve it, and I would definitely recommend you using them since there are some caveats if you do it manually, such as sub-pixel rendering and your screenshot being like 98% the same, given those unexpected and unpredictable rendering differences. You can use screenshot tests to check small reusable parts as cards, grids, or even buttons, But on the other hand, nobody prevents you from testing whole pages with screenshot tests. Keep in mind that the chance of you invalidating a test for the whole page is really high, and you might find yourself into just updating the screenshot over and over again since you expect it to change anyways. Now let's talk about kind of broader of screenshot tests. It's called snapshot tests. It's not exactly the same, but conception is quite similar in a way. Idea is that we take some components, usually again reusable stuff, and we render them into HTML. Those HTML snippets which we get in output are called snapshots. Again, idea is quite the same. When you run your test for the first time, you're gonna create a reference snapshot. Each consequent run of the test is gonna create a new snapshot, which is gonna be compared to your reference snapshot. If it's the same, test is successful. If it's different, test fails. In reality, every time you're gonna change something in your application, you're gonna invalidate some snapshot tests. Therefore, they're really useful only for small and reusable pieces, and not really useful for the large chunk of the apps. Personal opinion alerts, I think that this high frequency of invalidation and a little bit decreased trust to this sort of tests, since people just override them over and over again, is the reason why they're not so popular in development community. Okay, now when we know what kinds of tests exist, the good question is gonna be when to write which kinds of tests. So, okay, let's summarize everything what we were talking about before and finally decide what kinds of tests we need to write. We need to account for the fact that everyone is gonna have different applications, different conditions, and different testing situations as well. There are some good strategies out there. If you are just starting and you have enough resources, probably you can consider something like TDD, which is also known as test-driven development, and it just works, it works well, but there are many companies out of there who couldn't afford it, and it's also okay. I want to ask you not to fall for some article which says that TDD is gonna solve all your problems, and first, think for a second why we are gonna write tests for. Frankly, you get reviews. With tested code, you don't need to do manual regression every time you go to production anymore, so we can incorporate some continuous delivery into your workflow. Second, obviously you improve your stability and uptime. And third, when you keep the testing side of the things into consideration as a developer, you often find some edge cases you didn't think in the first place. It increases your code quality as well. Therefore, your questions should consist out of the several parts. First, how quickly those tests are gonna be executed. How much time is it gonna take to write those tests? And also, how can I guarantee that business flows can be completed? There is quite a common approach in the industry, and it is called testing pyramid. It's pretty good with a small asterisk. And the asterisk is that it just isn't so good for the front ends. During the maturing of front-end community as a whole, there were different opinions rising and stagnating, but many of them had some conceptions in common which partially resemble this testing pyramid as well. And we're gonna focus on those similarities. The common rules are that it's good to have a lot of cheap tests and not so many of expensive ones. It enables you to run your tests quick and deploy more frequently, but also it enables developers to run more tests when they develop locally. If you have many end-to-end tests, you couldn't expect people to run all the tests locally, so your pipelines are gonna be abused, since it's just not relevant or could be even impossible to run all tests locally every time. So focus on cheap tests, avoid tons of end-to-end tests unless it's absolutely necessary for your business. Second rule is that reality is not perfection. Try to focus on covering the most important tests first. Try to focus on writing a test for the most critical parts of the app. Once they're there, extend them and cover more and more scenarios. Second rule is try to keep a balance between different business priorities. What I mean, for the most important crucial parts of your business, the most critical business flows, try to write end-to-end tests to ensure that everything works well together. The less important features, the ones which don't really break the application apart and cause just a minor inconvenience, it's good to have unit tests or integration tests. Don't test libraries and frameworks. Chances are they already tested, and if they are not, why do you even use them? Rule number 4. It really depends on the framework you use and architecture behind it. If you have something component-based, it's a really good idea to have a bet on integration tests. Okay, let's think together. First, we check the whole component, if it works, if it breaks. It's an easy test to write. It's very straightforward since you interact with the component and you pass properties in it and see how it behaves. It's also a very cheap test to run. It doesn't take much time on a pipeline, and it still can be executed locally in a reasonable time. Given said, it scales really well. So, I hope this video was useful to you and will help you on your front-end testing journey. If I made any mistakes or you wanna add something, please let me know in the comment section below. See you next time.